we will explain how to find the decimal expansion for the square root of 2. And we will use the iterative method to address this question. But first, let us denote square root of 2 by x. So x equals to square root of 2. And therefore, x squared equals 2. And so basically finding the decimal expansion for the square root of 2 is equivalent to solve this equation, x squared equals 2, and find the decimal expansion for x. So from now on, we will concentrate on solving this equation. Before describing the method that we will use to solve this equation, I would like to pose several questions. So the first question is whether this equation has an integer number solution, meaning that whether x can be an integer number. That this is not possible. One can quickly check by manually verifying the first integer numbers. For instance, for x equal 1, the x squared would be equal to 1, which is not equal to. So x equal 1 is not a solution. For x equal 2, x squared equals to 4, and that's also not equal to. And for the next integer numbers, 3, 4, etc., their squares would be even higher numbers and not equal to 2. Therefore, we conclude that this equation has no integer number solution. Second question is whether this equation has a rational number solution, meaning if x can be equal to a rational number p over q. The p and q here are integer numbers, and their ratio is a rational number. So the question is whether this is possible, which would mean that p over q squared equals 2. Answer to this question is negative. There is no such a rational number whose square equals 2. Unfortunately, we cannot manually verify this statement by manually checking the rational numbers, but one can strictly prove this statement, and you can find the proof elsewhere, and I will also make a separate video explaining and presenting the proof. The third question is whether one can find rational numbers, p over q, that are approximately equal to x, which means that the difference between the x and the rational number is small. And then the p over q squared would be approximately equal to 2. And the answer to this question is positive. The method that we will describe next will help us to find such rational numbers that are close to x. And in fact, this method helps to step-by-step construct rational numbers that are getting closer and closer and becoming a better and better approximation for x. And I would like to one more time remind you that the x and the square root of 2 are the same, as we said at the beginning. So all the statements that we made up to now about the x is also true for square root of 2. So the bottom line is that the square root of 2 is never equal to a rational number, but it can be approximated by rational numbers. And once we find this rational number, p over q, we can write the decimal expansion of that rational number. And then we can use this decimal expansion to represent x as well. Of course, one should keep in mind that only some finite sequence of digits in the decimal expansion of p over q will match with the respective digits in the decimal expansion of x. And this is because x and p over q are only approximately equal to each other. Now we describe the iterative method for solving the x squared equals to 2 equation. So let us start with the first step of this method. At this step, we need to guess a number whose square approximately equals to 2. And we don't need to make a very accurate guess. So I will pick x equals to 1. Now the square of this number, x squared, also equals to 1, and that's not equal to 2. But this is okay because, as I said, we don't need to be accurate. Still, it is not true that x equals to 1, so better denote this as x1 and write that x approximately equals to x1 and x1 equals to 1. Now we do the second step. We write that the exact solution x equals to x1 plus some number which I will denote by delta. So the delta is a correction. It is such that adding it to x1, you get the exact number. And since x1 equals to 1, then we can write this as 1 plus delta. Now the task is to determine delta. To do this, remember that the x squared equals to 2, and therefore 1 plus delta squared equals to 2. Now we open the brackets on the left side of this equation and we obtain 1 plus 2 delta plus delta squared equals 2. Now notice that this is a quadratic equation, and the solution of this equation, in fact there are two solutions, is expressed in terms of square roots of some numbers. But since our original goal was to determine the decimal expansion of the square root of 2, then if now we express the delta in terms of square roots of some numbers, some other numbers, then we are kind of back to the original problem, and we will need now to find the decimal expansion of those square roots. And since we want to avoid this scenario, then we need to simplify this equation. And to do that, I will make an assumption. I will assume that delta, or the absolute value of delta, is smaller than 1. Meaning that delta is a small number. Now, if delta is small, then the delta squared would be even smaller. And therefore, in this equation, on the left-hand side, we can drop the delta squared term, because this term, this quadratic term, is much smaller than the linear term 2 delta. So to give you an example, if delta is 1 over 10, then the delta squared will be 1 over 100. So we can drop that term. So we will drop this term, and we will end up with the following linear equation: 1 plus 2 delta equals 2. Solving this equation, we will find that delta is equal to 1 over 2. Now we can check the assumption. Indeed, the correction, the delta, is smaller than 1. And we can plug this number into the expression for x, and we will have that x equals 1 plus delta which is 1 plus 1 over 2, and this is 3 over 2. Now, let's check the square of this number. We'll have that 3 over 2 squared equals to 9 over 4, and this is 2.25. Now, this is very close to 2, so this is approximately equal to 2, but it's not exactly equal. So that means the 3 over 2 is not the exact solution, so we cannot write that x equals to 3 over 2. Let us instead denote this as x2, and x is approximately equal to x2, which is 3 over 2. And you might wonder why we ended up finding not an exact solution. The reason is that instead of solving the exact x squared equals to 2 or 1 plus 2 delta plus delta squared equals to 2 equation, we dropped the delta squared term on the left side of that equation, which is indeed a quite small term. It is 1 over 4 in our case, but still it is not 0. And therefore we ended up finding only an approximate solution.